this first. Okay. Okay, let's just say today I want you to graph wait, what's the first function? Y equal to what?
1 over x minus 5
plus 2. And let's just say if I want to graph that. But understand there was a parenthesis right here. So this, usually inside the parenthesis, is going to go opposite from the sign. So this is going to be right 5 and up 2. Right 5 and up 2. Right? So that means what is right 5 and up 2? It's the anchor point of asymptote. And that asymptote is going to go in. You say, okay, well, I'm going to go right 5 up to, and it's going to be this point right here. And this is where the anchor point occur. So it's going to create the asymptote based on this point. It's going to create two asymptotes. One is horizontal, one is vertical. So it's going to be like this. I don't know what the function restriction is. I think it's probably x greater than -3.
Yeah, no, just 3.
3. Okay, thank you. So then you're going to stop the graph right here. Now, some people says, do I eyeball it? Well, the only thing I want you to draw out, which is not on Desmos, is the asymptote of vertical and horizontal. Now, if this is a, let's say this is a positive one, it should go into exactly 1 unit across diagonal here. If this is a 1, so this is going to go like this, but it's going to go towards asymptote. It's not going to curve back. It's not like this. It's going to go toward the asymptote. It's like abyss. Like she's going to drop like, you know, and then this one's going to go here, and this one's here. So that is how you draw that. But everything else is eyeball, yes. You just go toward the asymptote. That's the only thing. You just think about it as a strong current. It's going to go toward a current.
The point you started with.
Yeah, they are two of them, yes. If you grab on the Desmos, if you see here, I'm going to show you on Desmos. So if you do your homework, please check your Desmos, like I say. Here it's going to be 1 over x minus 5, right? Plus 2. And plus 2 here. Oops. Well, that doesn't matter. And the restriction is x is greater than 3. And it's going to be like this. And if you want to show you that y equal to 2, and it's going to be some dotted line like this, and you can see that x is equal to 5. It's going to be some dotted line like this, and yes. And this is what an asymptote look like. And you see that it's 1 unit apart here, and it's 1 unit apart. It's like kind of diagonal for the things. You just had to go to that specific point. Now, for me, that part I'm not very really emphasize on it. Now, what if I change this to 2 here? It's it's gonna be away, so it might not be exactly 1 unit away. It's like almost like the second point is 2 units away, but that doesn't really matter. From that, I don't really care, because that number doesn't matter. That number can be like 17. I don't know. It's just gonna be bigger. It's just gonna more away. But for me, if you generalize that graph, it's fine for me. Is that okay or no? Okay, any other questions? Are we okay here? Can I move on? Okay. I want you guys to think about what would this graph look like. Y equal to x squared minus 4 over x minus 2. Okay, so This is the first time you see this graph. Now I want you to take a guess. You okay? That's good. Let's start with it. Somebody's guessing parabola, but that's okay. We don't know if it's true or false. We're gonna say that's.
It's a lie. It's a lie.
Okay.
A slow lie. No, it is. It's a lie, actually.
Okay. So Shreya says it's gonna be a parabola. Could be a
No,
line.
it's not a problem. It's just a lie. It's just a lie.
Okay. Anybody else? What'd you say? A lie?
No, it's just like a slow lie.
What's Harper? She did? Switch to where? That's okay.
Oh yeah, she'll probably think.
I know she don't like me.
Everyone doesn't want to take you. Take all these.
Oh. That's okay. I understand.
Oh my.
It's okay. I'll never switch out of your class.
Please switch it out. Please, Arthur. I send you a pass right now.
I'm gonna kill your.
I'll write you a pass.
Your pass rate will always be tainted by my playing system.
I'll write you a pass.
Yeah, hey, you know, he used to have 100%. Arthur should have more. No, he has one exception, I think. Right?
Huh?
Your pass rate, literally Diego is like one guy.
I love Diego though.
Exactly. You love me. I probably will.
Diego is lovely.
What's Diego? For Catholics or
He's so funny. All right, so
that's literally me. But I'm better because I'm funny.
now the problem is switch it over there and it's behind over there because the other class is way ahead. So I mean it will be easy A though. X squared minus 4 over x minus 2. What's Elizabeth?
Oh, she left early. She said her head blew. She hit it and now it's pounding.
Okay.
Literally, I don't know.
All right, so somebody says, anybody else suggest what does graph look like besides? Yes.
Y equals x plus 2.
Y equals x plus 2. Okay, good. So we're gonna see, but why is anything special about this line though? Can you also tell me like if it's a line, is anything special about this line?
Can't do it through positive.
Yeah. There's
And
a
then-
hole. There's a hole. No, wait. There's a. Wait, it's not called a hole. It is called a hole.
All right, good. So this one is a y. Now you're gonna look at a domain, right? What's the domain of this function? X cannot equal to 2, right? If x equal to 2 is not defined, then but you still can simplify. So this is gonna be x plus 2 and then x minus 2, and then that's over x minus 2. And if you cancel out, that's gonna be x plus 2. And then you say, oh, okay, well, that's just graph of x plus 2. But this is a graph of x plus 2. So this is x plus 2. And this is a x squared minus 4 over, over x plus 2, x minus 2, sorry. And you find out they are exactly the same. Right? You find out they're exactly the same, but there's slightly difference between those two graphs, slightly. So what I mean by slightly is this. Is you pay attention to here, and if I just scroll this value, so as I go into this value, and now scroll all the way to here, you don't see any difference, right? Well, let's go the other side. Well, oh, this is x plus 2, duh.
Yeah. The hole. I was.
Because x cannot plug in there. If x plug in there, it's not going to be defined, so there is something called a hole. And if it's a hole there, then how do we find that hole right? So you don't sleep.
Not again.
Okay.
I'm looking down and writing down. I'm writing down under my paper.
Okay.
It's called me a chink at this point.
So so this is simplify. This is simplified equation, right? This is a simplified equation. Now, what happened if you have simplified equation? How do you identify the whole? So you're gonna take the one that you cancel, and you said that you solve for that. You take cancel factor, so write down cancel factor equal to 0, and you're gonna say x equal to 2, and you're gonna take that 2 and take this 2, plug in the new equation, plug in to the simplified equation. Okay, plug in the simplified equation. So it'll be, well, 2 comma, sorry, the simplified equation is going to be y equal to x plus 2. Then if you plug in 2, what will happen? 2 plus 2 is equal to 4. So it'll be 2 comma 4. And this is also known the whole. The location of this whole is very important. So I need you to find the coordinate of the whole on the test. In order to find the coordinate of a whole, you have to take a cancel factor. You set it equal to 0. You set it equal to 0. And then you plug in to the new simplified equation to find the y coordinates. Okay, so you got a whole. So now you can graph a line, that x plus 2, which is we all know show how to graph. So x plus 2 here. So this is gonna be like this, a whole. And this line is gonna be like here. And this line is gonna be like here. And that's gonna be a hole there. Is that okay? You good? Now I'm gonna change just slightly. Not too much. I'm gonna flip. I'm gonna flip this. I'm gonna ask you to graph, and I want you to think about everything that can happen. Just try your best. Don't shout it, because if you shout it, other people stop thinking. I want them to thinking about. I want a student to think about those things. You do know how to graph this one, but it's a little bit different than before. Slightly different, a little bit of what you learned yesterday, a little bit of what you learned today. So a little bit of everything. Don't shout it. If you shout it, other people stop thinking, so don't shout it. Just, you can talk to with your group if your group are. What? You can graph it. Yeah, see what you can find though is it's a you know, think about what you learned yesterday and think about what you learned today. So it's kind of combination of both. All right. So let's worry about this. So do you guys remember how to find domain? Domain of a rational function is looking for x squared, the denominator. So set denominator cannot equal to 0. So there will be x squared minus 4 cannot equal to 0. Is that okay? So this one can factor, so it'll be x plus 2 and x minus 2 cannot equal to 0. Is that okay? So x plus 2 cannot equal to 0, x minus 2 cannot equal to 0, x cannot equal to negative 2, x cannot equal to 2. Am I going too fast or no? So we know that those are not going to be defined, but we're going to change this to a little bit. We're going to factor this, right? We factor that. And can we simplify?
Yeah.
But when you simplify, make sure you hold something in place. That means you cancel like this. Please write down a 1 next to it. If you don't write 1 next to it, you would think it's x plus 2. But as a 1 next to it, then the new function, the new simplified function is going to look like this. Did anybody got x plus 2 only? You did? Okay, so make sure you hold that in place. Write down a 1 next to it. So that way it's 1 over x plus 2 rather than just x plus 2. David, what are you saying?
I did that and then I fixed it.
All right, good. As long as you fix it, it's fine. But if you didn't get it right, just change it. Just make sure when you cancel out, that's gonna be cancel out like holding in place, write 1 next to it. That's a very good habit of people. Like a lot of times, it's building a correct habit to do the right thing. Okay, so y equal to x plus 2 now. Now we actually know how to do this because you think about it. That just means 1 over x plus 2 plus 0, right? Does that make sense?
Yeah.
So then that means the graph is gonna go just like what we did yesterday. It's going left or right? Left to right. This is a new point. This is a point that's the anchor point. Create 2 asymptotes. And create 2 asymptotes like this. And since this is a positive, it's going to be first and third quadrant. So it's going to be going from here and like this. And again, it's going to go toward the asymptote. It's not going to get away. It's not going to lean away. It's going to get so close to it, but it's not touching it. It's going to go so close to it, but it's not touching it. However, there's something else happen. There is a cancel factor. Do you remember that cancel factor? The cancel factor is what? It's x minus 2. Right? You take the x minus 2 equal to 0, x is equal to 2. How do you find the y coordinate of the cancel factor? How do you find the y coordinate of the cancel? How do you find the y coordinate of the whole? Plug into where? The simple one, not the old one. So you plug in this into the simplified one, which is 1 over x plus 2, which is new f of x is equal to this. I'm going to plug in 2 in there. So it'll be 1 over 2 plus 2 is equal to 1 over 4. So it'll be 2 comma 1 over 4. Is that okay?
Yes.
So here, this is 1 over 4 here. This is actually a hole right here. This hole is going to be 2 comma 1 over 4. And this is the graph. Arthur, do you understand? Or are you falling asleep? Yes, Tree.
You would have to graph or identify the angles.
You have to find the answer and also plug in the graph. You have to do both. Okay, yes, you. Yeah, go. I'm not writing a smart pass when I cross the street from me. Yes. The domain just says x cannot. Okay, so the domain, let's go back to write down domain and interval equation. So this one, it should be the value could be anywhere from -infinity to -2, union from -2 to +2, union from 2 to infinity. Union from 2 to infinity. So it's gonna be all those things. So that means I can plug in every value except I will plug in a value, can plug in any value between -infinity all the way to -2, and all the way from -2 to +2, and all the way from 2 to infinity, but not 2. 2 and -2 is not able to define, because if I plug in 2 or -2, I'm gonna get a number over 0. A number over 0 is actually a really bad thing happening, because you cannot divide by 0. Use a calculator. You just type in Google, says just type in that says let's say go to Google here, Safari, and that just type in like says 2 divided by 0, and we know 2 divided by 0 is going to be undefined. So anything is going to be undefined, right? Any number over 0 is undefined. Is that okay? Okay. And that's how I graph this. Any questions? Huh? What do you mean, what I add 0? Tell me where, hold on a second. Where? Here? 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 Oh, I just said, like, imagine that what we learned yesterday is 1 over x plus 2, maybe plus 1, right? This time it just, there's no number, it's a plus 0, so that means I only move left 2 units, I don't go up any unit. So I just want to show you I didn't go up or down as far as in terms that 2 asymptotes goes. So far, do you have any questions? Yes. That's okay.
Plus 2, so I have finally answered as x is equal -2 and y is equal 1 over 0. So we do not take this because because the 1 over 0 is undefined, right?
Yeah, 1 over 0 is undefined. But there was still a coordinate for that hole. There was still a coordinate hole because you had to go and draw it. You have to go in and draw it. And there's a coordinate on it. Okay. Yes, Roger? You're stretching? Okay. So just so you know, I forgot to change Harper, Roger, and Yop's grade because you guys all coming after school to work with me. And that's fine. It's not possible, right? So there's no x-intercept because there's asymptote. But is any y-intercept? Okay, y-intercept is where? Okay, y-intercept because you can plug in. So y-intercept, you can say, how do I plug it? How do I find a y-intercept? Y-intercept is plug in 0 for x, right? Plug in 0 for x. So therefore, it's gonna be if you can plug in original function, doesn't matter. So it's gonna be 0 minus 2 over 0 squared minus 4. So that's gonna be -2 over -4. That's equal to 1/2. So we know at this point it's also 0, 1/2. So we know a little bit additional points that we can get. The more additional points I want you to see is the better. Okay, the more additional points I want you to see is better. So yeah, so this is gonna be how to graph irrational functions. No, you can use a simplified equation. Good question. I think all you guys are producing very, very good questions. Any questions here? I have 18 minutes to talk about horizontal and vertical asymptote. So vertical asymptote is the denominator equal to 0. Denominator equal to 0. So in this case is x. Oh, sorry, it's not a denominator. It's the simplified equation. It's not the original equation. It's simplified denominator equal to 0. 0 simplify. So therefore, you can take the simplify, which is x plus 2. So x plus 2 equal to 0, x equal to negative 2, which is negative 2 is going to create this asymptote. The asymptote is, you're not going to touch the vertical asymptote. Now, however, horizontal asymptote is a little bit different. A lot of people think like asymptote is something you cannot touch. But horizontal asymptote is different. Horizontal asymptote, sometimes it can touch. Sometimes. Not all the time, but sometimes it can touch. Okay, only especially in the middle region. So that's, so you take the simplified equation denominator equal to 0, not take an original equation. If you take an original equation equal to 0, then you might find 2, but there's no 2 vertical asymptote. One is a whole, one's a vertical asymptote, so you gotta know which one's which. Now, how do you find the horizontal asymptote? Does anybody remember how to find horizontal asymptote? Huh? No, it's not a numerator. It's comparing the degrees. So we're gonna look at it, compare the degrees. So you're gonna be compare the highest degree of denominator versus the numerator of a rational function. Have you guys remember this or no? That's fair.
Mr. Gay was
Compare the highest degree of the denominator and numerator. So you compare both. So right now we're just gonna analyze only horizontal asymptote. We're not analyzing anything different. We're not look at the vertical asymptote, horizontal asymptote. We only look at the highest degree of numerator and denominator. Yes. Compare the highest degree of denominator versus the numerator of the rational function. Okay, so that's horizontal asymptote. Now, how do I compare? There was 2 things. If I'm gonna give you an easier one to think about it. Yeah, I can send it to you if you want. Okay, well,
The airdrop.
I can airdrop to you if you want. At the end. Is that okay? Just remind me.
I have a photo of like the last one. I just need the horizontal and vertical.
Okay. How much time I have? 14 minutes. Okay, that's good. So the degree, so if numerator degree, wait, sorry, is denominator degree is larger than numerator, then y equal to 0 is your horizontal asymptote. Y equal to 0 is your horizontal asymptote. If the denominator is larger than the numerator degrees, now if the numerator is larger, So if a numerator is larger, degree is larger than denominator, denominator, then it's going to be no horizontal asymptote. How many of you guys learned this in Algebra 2? Oh, good. Now, do you guys remember if the same degree? If the same degree, numerator or denominator, then you're going to take the coefficients.
Yeah, the leading.
Yeah, take the coefficients. And yeah, there's a slant, but slant only occur when numerator is greater than denominator. So you're gonna talk about this. You're gonna put a slant. You're gonna say possible slant. So possible slant, or also is also known as oblique asymptote. Oblique. Oblique is also known as oblique. Yes. That's only for numerator is larger. So if it's the same degree, then it's gonna be this. So what we're gonna do is we're gonna observe. We're gonna observe. So we're gonna use decimal to observe this and see if it's true. Okay. So I'm gonna name a rational function, and you're gonna tell me what is a horizontal asymptote. So I'm gonna name this function. For example. If, let's say 3x squared plus 6x minus 1 over 6x squared minus 2x minus 1. So I have these functions here. The highest degree is the one we are comparing with. So we compare to this one and this one. So are they the same degree, or which one's larger? They are the same degrees, right? So yes, your horizontal asymptote is going to be, just take the coefficient, which is 3 over 6, it's 1/2. It's going to be exactly at 1/2. Yeah, they both square, sorry. If they both going to be square, and that's going to be 1/2. Is that okay? So we're going to check if it's true. Can somebody tell me the equation? Give me a second, let me retype it. Let's say 3x squared. What was it? 3x squared? Minus 1? Divided by what? 6x squared? Minus 2x? Hold on a second, let me check. Let me check my minus 2x minus 1, right? Okay. And then you're gonna go ahead and sketch y equal to 1/2. And you're gonna see this. No, you're gonna produce some question now. So you see that there's an asymptote there? But here's the problem. What do you see? They actually went through the asymptote. They actually went through the asymptote. Well, it's not allowed. So that's what this misinterpretation is. So vertical asymptote, and I give you an analogy. I know my analogy is gonna offend some people, but I don't really care. Now Arthur's gonna wake up because I'm gonna offend people. So the way I kind of think about this, it's like vertical asymptote. It's like if you are gay.
Oh.
It's like if you know they're gay, you can't prove it.
No. Like, let's just take, for example, if Arthur is gay. That,
Fuck, come on, man.
no, you would never have
At
a
least
chance.
say Krishan, like. That it's such an easy one to say.
Krishan has some type of game. No? Krishan don't have no game?
Wait, hold on, it's right there.
Uh,
It's right there at the beginning.
All right, no. Okay, so the way I kind of think about this is this. So, okay. So what happened is, the question is, hey, how come this crossed the horizontal asymptote? Now, the way to think about it, vertical asymptote is you never cross it. You never have chance like if like let's say if Ella like Arthur, but Ella is not gonna have a chance with Arthur because Arthur is gay. Because he's for sure gay. He's nothing changing. Now, the way kind of think about this is this. Horizontal asymptote only care about what happened eventually. So there's in calculus, I'm gonna explain you in calculus. In calculus is actually his limit x approach infinity of f of x. Is we only care about what happened infinity. Or what happened negative infinity. So in calculus, we call this, you're gonna learn this next year anyway, so I'm gonna show you how to do it. You're gonna approach infinity or negative infinity. This is a definition of horizontal asymptote. I know some of you guys are confused. Just bear with me. I'm gonna explain to you. It will start to make sense. So only happen later. You know how some people are not gay at the very beginning of their life. Okay, they experiment. Yeah, but eventually they say, no, I'm gay. So kind of think about it, the horizontal asymptote is what happened later in life. Like when they go to infinite, when time is infinite, are they eventually gay? So in the middle part of their life, they can cross the x-axis. Okay, they can cross their axis. So the way I kind of think about it is the vertical asymptote is that they are for sure gay. You just have no chance with this guy if you're a girl. Or if you're a boy, you have no chance with this girl. Okay, that's just for sure gay. But if they are like a horizontal asymptote is different. Horizontal asymptote is they will eventually become a gay, but you have a chance in mid part of their life because they will experiment two different things.
You're figuring it out, okay?
They're figuring out. Thank you.
Bi-curious.
Oh, bi-curious. Is that what they call it? Bi-curious?
Yeah.
So in the middle part of the graph, they can cross it. A lot of time in middle graph, they will cross. They don't have to. Not all the time. See, pay attention. If I change to this to maybe like see like this, they actually cross it twice. Oh no, sorry. They actually cross once. But if I change it to negative sign, sorry, it's still crossing once. But eventually, look at it. Eventually, it still become an asymptote. It won't cross. But the middle part is fine. The middle part is they can cross. It's okay. But eventually, when limit x approach infinity, if you look at all the way to 100, right? Eventually, it's never touched the dotted line. But in the region in the middle, they can touch in the middle. I don't know if that analogy makes sense. The way to think about it, vertical asymptote is for sure gay. Horizontal asymptote is they will eventually become gay. But in mid part of their life, you have a chance against this person. Not just say, if I like this girl, and hey, in middle part of the life, I have a chance because they're still trying to figure out. But they figure out, they're like, oh, I'm gonna dump you because I'm gay. I don't know. I don't want to offend anybody, but I don't care. Okay, does that make sense or no? Okay, so hopefully that I like to create imagery for you to learn something. I don't like to like just boring because math is a very boring subject. If I just say, oh yeah, that's a horizontal asymptote, yeah. So I'm gonna print a shirt that says you are horizontal asymptote. So
I'm horizontal, you're vertical.
that's okay. I'm vertical. You're not offending me. I don't really care. Okay, does that make sense? Okay, well, what's second example? Let's say it's 3x squared plus 6x minus 1 over 5x to the third plus 2x. So what do you think the horizontal asymptote is located at right here? Not 3 over 5, no. Zero, yes, because the top part degree it'll be 0. That because this and this if I were to teach you calculus, then you will have to divide it by highest degree of denominator, but we're not gonna get that far. So what happened if you have the other way? Let's just say 5x cubed plus 2x over 2x minus 1. So is any horizontal asymptote here? No, there is no horizontal asymptote. No horizontal asymptote. And you can see it. Look at this. 5x cubed plus 2x. I'm definitely going to get canceled by Republicans, but
It's fine. It's fine.
2x
We live
minus
in a
1.
blue county.
I'm in the red state though.
In a red state.
I'm in the red state.
To stay within
So if
the
you all get
OCPS
me
boundaries.
fired, just film a clip and just report me to education. I'll get fired.
No,
And
but
I'll be on
Republicans
Channel
don't like
Fox
it.
and I'll become popular.
Like, that's my teacher.
Huh?
Who's gonna teach me?
It ain't gonna be Ollie, bro. It ain't gonna be Ollie.
No, Audie is good teacher. Okay, so do you see that there is no horizontal asymptote here? But there was something else though. Shh. There was something else. There's actually a second degree asymptote, which is usually people don't know about this, but if you do long division of this, you're gonna find out there's actually a asymptote look like a parabola. So that's just a little bit out there. You don't have to know this, and the AP exam doesn't require this, but their asymptote look like parabola, by the way. Huh?
Like, you learn that.
Actually, you don't. You don't learn that. I just know it, but you don't learn that.
No, we have.
Okay, so hopefully you guys know about vertical asymptote and horizontal asymptote. By tomorrow, we're gonna put everything kind of together to grab different kind of rational functions and everything.
Can you live stream tomorrow?
Yes, you're gonna be swimming, right? Wait, you're gonna be swimming or no? Huh? I cannot see.
I have one of that. Not even gonna
With the same degree, take the coefficient. Yeah, possible slant and oblique asymptote.
There's like different tickets. I don't know.
Yeah, the asymptote look like that. Yasmin, come here. No, I will grade it today. Sorry.
Might just be in the same place. I don't know.
Is this class a little bit better to easy to understand?
Yeah.
Okay.
I used to know the asymptotes, so I got confused when it came to when we did the derivative. And they did that.
Okay, well, right now you just have to compare the degree, which is a lot easier. Yeah.
Go ahead. Take off.
So I need to put you in the AP classroom for this one. And remember, if you didn't do well on tests, come back trying to understand them, because actually you,
I asked mostly Misha and Amelia for help with that.
who? Amelia?
And Misha.
Amelia is probably better into that. The Ukrainian girl?
Yeah, Ukrainian.
Yeah, she haven't shown up to school. Is she okay?
Dad.
He's sick. He's vaccinated.
She's sick. Okay. Yeah. What's up?
I'm absent in Italian class. Will you tell the Italian teacher or no?
Oh, it's okay. Nobody cares. Yeah, at this school, absence like nothing. People absent left and right. No one cares. It's gonna report to me. It's gonna be like, your child have absent one period.
It was bad enough.
Hold on. How do I do
Okay, pass you.
what?
You know Mr. Puan's test.
How'd you do?
Yeah, I got a 95.
Oh, nice.
You're in BC.
Yeah, but the problem is, how do I get to AP?
You click that arrow.
But how do I go into the classroom? Because there was I'm not in the right place. Hold on. Am I in the right place? Student view? No, community. How do I ask student?
Well, I can put in the code.
Yeah, but I need to find a code for you. AP.
How are you,
Awesome.
Devin? Because you usually.
Oh yeah, this educated. Wait, what?
I'm a student.
Do you understand stuff?
No, I'm gonna go look at your screen. I'm there. It was a combination of wanting to go to sleep, and then,
I know. You look very tired.
but I was trying to not do it. 'cause
I
we
know.
get started.
I appreciate today.
Oh, I'm
You
sorry.
really. I can see you really try.
And when you said gay, I went, okay, let's go.
Yeah, when I say I'm gonna offend somebody,
I
and the
need
kids
to
like
hear
wake
it.
up like this.
But I'll go look at the live stream. Hey, did you end it?
Isn't it Jordan?
Yeah,